So when you're deep in your Python code, you're always trying to follow that golden rule, right? Don't repeat yourself. But that simple idea leads you to a massive design choice. Should you use inheritance or composition? Honestly, it's one of the oldest debates in programming, but getting it right is the secret to building software that's clean, easy to change, and isn't going to give you a major headache 6 months from now.
Check this out. Inheritance is often overused. Whoa, that's a pretty bold claim, especially since for a lot of us, it's the very first tool we learn for code reuse. But you know what? A ton of experienced Python developers would nod along to this. The idea is that inheritance can sometimes be a trap, locking you into these really rigid designs. We're about to see exactly why that is and what you can do about it. All right, so here's our game plan. First, we'll talk about the code reuse dilemma itself. Then we'll dive into inheritance, the classic solution, before looking at its super flexible alternative, composition. After that, we'll get into some special Python tools like Mixins, and we'll wrap it all up with a practical guide for choosing the right design path for your own projects. Okay, so this is really the heart of the matter, isn't it? We all want to write our code just once, but at the same time, we need it to be flexible so we can change it later without breaking everything. So the question is, how do we structure our objects to do both? Let's start with the classic answer that everyone learns first. And yep, that first answer is almost always inheritance. It just feels so intuitive, right? You take a general idea and you create more specific versions of it. It's all built around that really simple concept, the is-a relationship. So inheritance is all about specialization. A child class or subclass gets all the stuff, the attributes, and the methods from its parent. Let's take a simple HR system. It just makes sense that a manager is an employee. So the manager class can inherit the basic name and ID from the base employee class, and then just add its own manager-specific things. It seems simple enough, but this is exactly where the trouble can start. But what happens when things get just a little more complex? Imagine your company now wants to add a productivity system. Well, suddenly, a salaried manager's productivity is tracked differently than an hourly factory worker's. So what do? Do you create a salaried manager with productivity class and an hourly worker with productivity class? All of a sudden, your nice, clean inheritance tree just explodes. You're stuck creating all these hyper-specialized classes for every single combination, and your whole design becomes this rigid, unmaintainable mess.
And that mess brings us to composition, which is a much more flexible and, I'd argue, more powerful approach. Here, we're going to stop thinking about what an object is, and we're going to start thinking about what an object has. It's a total, fundamental shift in your mindset.
So think about it like this, where inheritance creates this really tight bond. A manager is an employee, and that's forever. Composition creates a loose one. Instead of a manager being an employee, we now say an employee has a payroll policy, and it has a productivity role. These little policy and role objects suddenly become interchangeable parts that we can plug and play. And look at the result of that shift. We are back to a single, beautiful employee class. That's it. When we create an employee now, we just pass in the specific role and payroll objects it needs. It's literally like building with Legos. We're just composing a complex object from all these small, independent, and totally swappable pieces. And here is the real magic. With composition, you can change an object's behavior at runtime. So imagine a manager who is on salary switches over to an hourly contract. In that old inheritance system, that's a huge pain. You might have to create a whole new object. But with composition, look at that. It's just one line of code. You just swap out the salary policy object for a new hourly policy one. Done. The employee object itself didn't change at all, just one of its components. That is flexibility. And that's the result. We have completely collapsed that messy, exploding tree of classes back down to one. Just one flexible employee class. It's clean, it's simple, and it's completely adaptable to future changes. That right there is the power of this approach. Of course, this is Python we're talking about, so there are always more tools in the toolbox. Beyond just inheritance and composition, Python gives us some really clever tricks for specialized situations. Specifically, we're going to look at Mixins
and Python's unique take on multiple inheritance. So first up, Mixins. Now, a mixin isn't really a parent class in the normal sense. It's more like a feature plugin. You can think of it as an includes-a relationship. So for example, your employee class could include the ability to be converted into a JSON object just by mixing in that one piece of functionality. So let's look at this really simple meta mixin. It defines one method, get_meta title, but inside that method, it calls something else, self.getObject.
Which, of course, raises a pretty obvious question. Where is getObject? It's not defined anywhere in the mixin. If you try to use this class all by itself, your program would crash. So what's the deal here?
Well, the trick is that a mixin is cooperative. It's not designed to work alone. It's built with the expectation that it will be mixed in with another class that promises to provide that missing getObject method. As long as the class you're mixing it into holds up its end of the bargain, you can plug this reusable behavior in absolutely anywhere you want. It's a pretty clever pattern.
All right, now for a topic with a truly dramatic name, the deadly diamond of death. This sounds terrifying, and it's the classic problem that gives multiple inheritance such a scary reputation in a lot of other programming languages.
Okay, so here's the setup that creates this so-called diamond. Picture a base class. Let's call it A. Then you have two other classes, B and C, and they both inherit from A. And to complete the diamond, you have a final class, D, that inherits from both B and C. Now, if A has a method, and you call that method on an object of class D, which path does the code take to find it? Does it go up through B first or through C? In some languages, this ambiguity is a critical, deadly problem. But here's the thing. In Python, this diamond, it's not deadly at all. It's not even really a problem. That's because Python has a very clear, very predictable solution built right into the language, the method resolution order, or MRO.
See, Python doesn't guess. It creates a predictable linear search path for every single class. You can even print it out and look at it. The MRO is just a simple list of all of a class's ancestors in a very specific order. When you call a method, Python just walks down that list and uses the very first one it finds. No ambiguity, no conflict, no deadly diamond. Problem solved.
Okay, so we've covered a lot. We've seen the potential rigidity of inheritance, the awesome flexibility of composition, and the special cases where mixins come in handy. So how do you actually choose? Let's boil this all down to a simple playbook you can use. Here's your cheat sheet. It's pretty straightforward. When you need to model a true specialization, a genuine is-a relationship, go ahead and use inheritance. When you just want to add some optional features to a class, think about mixins. That's your includes-a relationship. And for pretty much everything else, especially when you need flexibility or want to build things from components, you're going to want to reach for composition. The good old has a relationship. So if we had to boil all of this down to one core piece of advice, it's this. Prefer composition. It's going to give you more flexible, more adaptable, and more loosely coupled designs in the long run. Keep inheritance for those really clear-cut is-a situations where it perfectly models the problem. And use mixins as a clever way to sprinkle in reusable behaviors where you need them.
Which leaves us with one last question to leave you with. After seeing all this, is a really deep inheritance hierarchy a sign of sophisticated design, or is it just kind of a bad habit? A relic that we've carried over into a modern language that gives us much better, much more Pythonic solutions. It's definitely something to ask yourself the next time you're about to type class, my class, some other class.